Did you know that uranium is the heaviest element found on the periodic table? Hi everyone, this is Mr. Lara, and in this video we will learn about the periodic table of elements. So what are elements? Elements are the smallest unit of a substance, and an atom is the smallest unit of an element. Elements combine together to form compounds, and atoms combine together to form molecules. We cannot see atoms with our eyes because they are so small, so scientists have to use very powerful and special instruments to observe them. So what are atoms? Atoms are the building blocks of all matter, and they're made up of protons, neutrons, and electrons. Protons and neutrons are clumped together in a small space in the center of an atom called the nucleus. Electrons move around outside of the nucleus in a space called orbitals. Each orbital has a limited capacity for how many electrons it can hold. Protons are positively charged particles, and electrons are negatively charged particles. Neutrons do not have a charge and are neutral. That's why they're called neutrons. The number of protons in a nucleus match the exact number of electrons orbiting around the nucleus. The number of protons, neutrons, and electrons in an atom determines the properties of the element. Scientists have arranged all of this information on a periodic table. In a periodic table, you'll find both columns and rows where elements are listed in order of increasing atomic number. But let's start by looking at elements in the periodic table. Each element within the periodic table is represented by one or two letters. For example, the element hydrogen is represented by the letter H. The element lithium is represented by the letter Li, and calcium is represented by the letter Ca. We can find the atomic number in each element located right above each letter or group of letters. The atomic number is the total number of protons found in that element. For example, hydrogen has an atomic number of 1, which means it has 1 proton. Lithium has an atomic number of 3, which means it has 3 protons. Sodium has an atomic number of 11, which means it has 11 protons. And magnesium has an atomic number of 12, which means it has 12 protons. The atomic number represents the total number of protons found in the nucleus of each element. Right below the name of each element, you will find the atomic mass, or the total mass of each element. For example, titanium has an atomic mass of 47.88. Borium has an atomic mass of 264. And zinc has an atomic mass of 65.38. Only protons and neutrons contribute to the mass of an atom. The mass of an electron is so insignificant compared to the mass of a proton or a neutron. In comparison, a proton weighs 1,836 times more. The atomic mass tells us the total number of protons and neutrons found in each element. So how are elements arranged in a periodic table? If we look at a periodic table from left to right as we read a book, we will notice that all elements are arranged in horizontal rows according to their atomic number in increasing order. These rows in the periodic table are known as periods. There are a total of 7 periods in the periodic table. The rows in a periodic table tell us how many orbitals an element has. These orbitals, also known as shells, are positions that surround the nucleus of an atom where you'll find electrons. All elements in the first row or period have 1 orbital. In the second row or period, they have 2 orbitals. Elements in the third row have 3 orbitals. In the fourth row have 4 orbitals, and so on. For example, hydrogen and helium are listed in the first period. Both hydrogen and helium only have 1 orbital or 1 shell. The elements in the second period, such as lithium, beryllium, boron, carbon, and nitrogen, all have 2 orbitals. The elements in the third period, such as sodium, magnesium, aluminum, and silicon, all have 3 orbitals. Elements in the fourth period have 4 orbitals. All elements in the fifth period have 5 orbitals, and so on. The sixth and seventh periods have so many elements that some of the elements are repeated at the bottom of the periodic table. Elements are arranged in vertical columns in the periodic table called groups. There are 18 groups or columns in the periodic table. Elements within each group have the same number of electrons in their outermost orbital or shell. These electrons are also known as valence electrons. For example, elements in the first group, hydrogen, lithium, sodium, and all of their elements in this group have only 1 electron in their outermost orbital. Elements in the second group, although they're all in different periods, all have only 2 electrons in their outermost shell. All elements in the third group have different number of shells, but all 3 electrons in their outermost orbital. This pattern repeats itself in the periodic table of elements. Elements in the seventh group all have 7 electrons in their outermost orbital and need only 1 electron to fill their orbitals completely. All elements in the eighth group have their outermost orbitals completely filled with electrons. If we were to look at group 6 in our periodic table, we will notice each element is in a different period, which means some elements have more shells or orbitals than others. However, what they all have in common is that they each have 6 valence electrons in their outer shell. For example, oxygen has 2 shells, while sulfur has 3, but they both have 6 valence electrons in their outermost shell. Let's review what we just learned. Elements are arranged in a periodic table by periods and groups. The atomic number of an element is located right above each letter or groups of letters and tells us the total number of protons found in each element. The atomic mass tells us the total number of protons and neutrons found in each element. All elements in a period contain the same number of shells. All elements in period 1 contain 1 shell, in period 2 contain 2 shells, in 3 contain 3 shells, and so on. Elements are also arranged in groups. A group tells us the number of valence electrons in the outermost shell of the element. Elements in a group have a different number of shells or in different periods, but they all have the same number of valence electrons.